Cool.
And by the way, you're welcome to take your seats. Yeah.
Hi, everybody. My colleagues and I work in one of the most successful project management systems, and we're trying to bring our clients the best product they can have, flexible, tailoring their needs. And today I'm going to tell you about the feature which is specifically tailored for our customers. And let me introduce myself first. Again, I'm Daniil, and I have this thing. And I'm a Wriker, and I'm working in an internal backend unit. And we do things like just monitoring the performance and seeing the bottlenecks, improving around them. We are improving the technology stack. For example, recent Java 17 transition, this was hard. Upcoming Spring MVC integration. And we also take care of user data encryption processes. So what's Wrike? Wrike is a more successful collaborative work management system. And it was founded in 2006. It was steadily grown ever after. And currently it has around more than 1,000 employees around the world and 9 offices worldwide. One of them in Tallinn here. I've been there yesterday. I'm originally from Prague office, which is also quite nice. So yeah, we have a lot of clients. Our clients are small-scaled businesses and huge enterprise organizations with the strict requirements, especially when it comes to security. So what do we need to do? We'll tell about this in this presentation. I'm going to tell you about the feature development story, and I'm going to touch what is Wrike Lock, aka data encryption service we're using internally in Wrike. What is the essence of it? What are the key problems? And whatever came during our development of the feature. And in the second part, I'm going to tell you about the encryption as a service. Why did we need it? How did we come up to it? And some technical details to that project. So Wrike is a software as a service project, meaning that all the data is stored in our data centers, and we're managing all the customer data, which is quite hard. And we work hard to ensure that the data is stored and transmitted securely. But software as a service encryption is vital because you don't want to anyone just hijack your files and be done with your business. So we developed the Wrike Lock. The Wrike Lock is a feature which helps to manage the secure data storage for our customers by utilizing cryptography and decrypting and encrypting the data on request when reading from the database. Let's dive into the feature. Wrike Lock uses cryptography at its core. So for the cryptography, we need the encryption keys. The encryption keys is just a piece of information which you use in the encryption algorithm to encrypt or decrypt the data. Of course, this process is very simplified in this presentation. The encryption requires a separate talk for that. So for this kind of presentation, we just want to see that like data goes out, the encrypted data goes in. Data goes in, encrypted data goes out. That's it, or vice versa for that matter. We have data keys. Data keys encrypt all the data there is to the customer, which can be potentially sensitive, which are mainly strings, because ints cannot be derived. You cannot just derive the sensible information from the integers. There need to be some context to that. So we encrypt the strings. We count every string as a potentially sensitive information for our customers. And when we encrypt the data using the data key, we then store data alongside the encrypted key using this format. We have a device control 1 character in the front, then the data key ID to later retrieve the data key associated with this encrypted string, the encrypted data. So when you take the out data, you can see that this string is in fact encrypted. You see the key ID to retrieve the data key, and you can safely decrypt the data. We have multiple databases in multiple regions and in different platform layers, and we have specifically designed data keys for all of those layers. So this brings us to have a lot of active keys for a lot of platform layers. There goes the management difficulty of this solution. And we don't have only active keys, we also have just deprecated keys because we have a key rotation, which is a commonly used practice in cryptography because we need to rotate the keys. So whenever, every now and then, every company has its own policies on that. But we also have a solution which rotates the key without need to re-encrypt the whole data which was encrypted before. So we just have the active key, which remains to decrypt the data which was encrypted using that active key before. And there is a new data key, which is used to encrypt all the new data. So now we have multiple active keys, multiple current keys, the latest ones, and we need to manage all of them. What do we have to manage all of them is the account key. The account key is a single key which encrypts all the data keys within the account. Well, Wrike Lock is per account feature, meaning that account A cannot encrypt or decrypt data of account B, obviously. So the account key is a single key for the whole account which encrypts or decrypts the data key. It's stored similarly to how you store the data, meaning we have the account key ID and the encrypted data key bytes. We don't need the device control 1 character to see if it's encrypted or not because we do not store decrypted data key anywhere. That would be out of the policy. So this is a single point towards all the account encryption. Easy to manage, but not so much. Well, here comes the whole differentiator point of the Wrike Lock feature. The account key is encrypted and decrypted by request by the client, the owner of the account. And this is done using the Amazon Web Services key management system. So for those who don't know what's that, it's a cloud-based solution which lets you manage your keys. And for this matter, we just call it, like in this presentation, we call it master encryption key because AWS KMS is very complex on its own as well. So client manages each request to encrypt or decrypt the account key, which has the entry point to all the data keys in the account, and as a derivative for that, the data as well. With this approach, client is the sole owner of the whole data, and when he revokes access or something, we cease to decrypt or encrypt any data, which can happen at any time. But with great power comes great responsibility. This is a very powerful tool, and something can go wrong. And possibilities for a perfect disaster are countless. The Amazon server can go down. The client loses access to the AWS KMS, or we lose access to AWS KMS, or anything else. And the businesses, like enterprise-based solutions, they need to recover from it quite quickly and painlessly. So what do? When setting up the account, we have, when setting up the account with the Wrike Lock, we have their master encryption key, which is simplified for it's in reality the AWS KMS, ANRs, and etc., etc. So we encrypt the account key using that master key. We have the encrypted account key, we store it, and later on we can decrypt the account key using the master key, using the client's master key. So how do we avoid losing all the data if something goes wrong? Well, during the account creation, we also request client to have a public key, an asymmetric key, which would be used to encrypt the account key. And we'll get a specially encrypted account key using that public key they have. And when something goes wrong, things go south, they should have a recovery private key. We don't know ever about this key, and we just hope that they stored this key somewhere under the mattress, on the post-it note, on the monitor, whatever. We don't care. We need them to recover their data on themselves. That's their responsibility. But we provide that opportunity to them to recover if they lose the access to AWS KMS. So what's the problems? The problem is that every service with the Wrike Lock, integrated with Wrike Lock, reads the same databases and sends the request to AWS KMS potentially at the same time, potentially for the same accounts, which is generating a lot of latency. So next, we developers of Wrike went to way of microservices, which is not very easy. And well, the road to microservices is already covered by my colleague, Vyacheslav Tutic. And you can check the article on Medium, and there is a Russian version on Hubber as well if you prefer Russian. But in this topic, we will just touch this thing briefly, because actually I wrote the microservices, initiated the project I am about to share with you. So Wrike, in essence, is a distributed monolith. One huge web application where the services are built, deployed side by side, and despite the variety of services, it's still not a microservice platform, because services work with a shared database. And code is just in one huge monorepository. And several modules can contain most of the logic and share it between all the other modules. So what's the solution? Just extract everything into the microservices. That's easy, right? Just take the codes and put it in their separate repositories. Well, yeah, we work hard now to assure that every service can be extracted into them, their own repository and built and developed on its own. But it's a hard task, and we call, for each of those processes, we call this process a split. And during the split of one service, we discovered a problem. The service is very dependent on the Wrike Lock because it's working with the customer data. So it requires the integration with the Wrike Lock, the main functionality of which is located in one of those large modules. And we decided not to put all of that functionality, all this module, to the microservice, because most of the logic there is unnecessary for the microservice. And the microservice would be in a different repository, so we need to manage the library for that. And the logic is quite entangled, so it's very hard to just pull out the Wrike Lock and call it a day. And even if we could extract the leap, we don't really want it, because we want to decompose this module in the future anyways, when we'll take all the parts out of it. So the solution we came up with is encryption as a service. We want to encrypt the data and decrypt the data. There is nothing difficult to that, but we want to put this in every service which needs the integration with the Wrike Lock. And would it be a new service or an old service, there needs to be a very easy integration, just put the library there or the transition to the new service. So for that, we need a client library, which would do all the work related to the encryption on the client side, which is managing the encryption scopes, which is managing the encryption strategies for different kinds of requests and for different kinds of handles, like system scopes or user scopes, and etc. Then encrypting and decrypting data and communicating with the encryption as a service itself, with the server. So initially we thought that, okay, we have this task, just add the library there and send the data in and out to the encryption as a service. But this is not a very nice approach, because the data tends to be quite big in our company, can be potentially hundreds and thousands of kilobytes, which would slow down the communication. And it also doesn't allow us caching for this solution. So in order to address all the points, yeah?
Really? Megabyte size strings to encrypt? Or this is the other type of data that you're talking about?
Wrike can handle attachments also.
So you encrypt.
There is actually one very nice story where the client of ours was using Wrike as a torrent tracker, torrent, but just putting the videos there and films and stuff. We don't want that, but we need to be prepared for anything. So yeah, no caching. because we just cannot cache the data, which and hope that customer would need this same data in a couple of minutes or so. So in order to address all of the pain points, we decided to work with the data keys. This is simple, much simpler, and the data keys are fixed in size, up to 256 bytes in total, including the metadata. And the client library can cache the keys to avoid the multiple calls for the same keys every time. And so now we have a nice API. We want the current key for data encryption. When encrypting the data, we want the latest key, which is used for encryption, and the active data key by the ID for decryption. Because as I mentioned before, we have stored the data, encrypted one, and ID next to it. So perfect. We also need to differentiate if the Wrike Lock is enabled, because the Wrike Lock is a paid feature, and meaning not all accounts have it. And if Wrike Lock is disabled, we need to preserve the data which is came to our API, so not to encrypt the plain text data or decrypt the plain text data. But if we want to decrypt the encrypted data, then something went terribly wrong, and we need to notify the authorities. So just to recap, original approach was every service is calling databases and AWS KMS all the time simultaneously, possibly for the same account. And the new approach is there is a library to the service. It talks to the encryption of the service. And the encryption of the service does its work in calling the databases and AWS KMS. So let's move on to the server part. Wrike Lock Key Management Service, which is WLKMS for short and ugly. This didn't work out, so we just call it like this. The benefits of it, of the centralized approach to management of the keys, are fewer points of failure, easier to deploy change in key management, and decreased call in AWS KMS and databases. While calls to database doesn't actually put a lot of load to our system, the AWS KMS calls are the purpose why we have a lot of latency in our system currently for the Wrike Lock. Because typical amount of time to decrypt the account key is 300 milliseconds. And we got 300,000 requests to decrypt the account key a month for a single server. And this accumulates to around a day of services just waiting to decrypt the account key. And all of this just because we calling KMS for the same account keys from multiple places. And we estimated that implementing the Wrike Lock key management system would decrease the waiting time by 10 to 20 times. But we still need some caching. And we have two keys, remember? We have account key and a data key. So the data key cache on the server side is not a very nice idea, because we request the data key from the client side to the server, and server needs to just take it from the database and decrypt it using the cached account key. We already have a network I/O latency, so we don't need to. This difference is negligible. But the account key cache on the server side is very vital, because AWS KMS calls are very slow. And also the data key cache on the client library side is vital and very helpful to avoid multiple calls for the same keys on the client side. Now that we have all the caching solution in place, we have two caches, let's move on to limitations, because in Wrike we actually have a limitation of 35 minutes withdrawal deadline. This means if a client withdraws the access to AWS KMS, we cease to encrypt or decrypt any data, and the data is not accessible by us or the client, so nobody. And we went with a straightforward approach of putting the 5 minutes to data cache and 30 minutes to account key cache, which gives us a system where the maximum withdrawal time is 35 minutes, which might be hard to grasp at first, but let's review the example. So suppose the client sends the request for a data key to the encryption as a service. Encryption as a service requests the decryption of the account key from AWS. It receives the account key and sets a timer for 30 minutes in the future to remove this key from the cache. And it gives back the key, the data key, to client library, and everyone is happy. The client library has the key for 5 minutes, which in this example doesn't matter because we're looking for a maximum withdrawal time. So suppose in future, somewhere in future, just before account key cache is expired, any service would ask for a same data key or the data key which associated with the account. The data key can be provided immediately because the account key cache is not yet expired. So it gives it back, and then the timer goes off. Now we have a 5 minute, for the 5 minutes we have data key cache, and the account key cache is already expired. So it was expired. The data key was taken at nearly the end of the life of the cache on the client, on the server side. So the next, any next request for the data key would initiate the AWS access. And if we have withdrawn, if the client withdrew the AWS KMS access, then we will not have the key. So we had received the key for 5 minutes after 30 minutes from last call to AWS. And therefore, we have maximum possible time of less or equal to 35 minutes. Well, this approach already satisfies our needs, but we decided to go a little bit further to satisfy the most used accounts. And we came up with the idea for asynchronous cache wrapper, which would wrap the caches we have and present their sole functionality of providing the requested key at any time. But if the request came after the half-time of the key, it would request a renewal of the key at the same time. Let's take a look at an example because it's kind of hard to grasp as well. So suppose any client or the service, it doesn't matter, it's a cache wrapper, it's agnostic. So it requested a resource. The cache requests the resource from the provider. Provider gives the key. We are having here the example on 5 minutes for the data key, for example. And the cache gives back the callee its key. Then 2 minutes passed. We still have 3 minutes. We request the resource. Cache gives it. It has it. Now 3 minutes passed, which is more than the half time of the cache. And we request the resource. So the cache has the key. It immediately returns the key to the callee, but it also at the same time requests the resource from the provider. Now the callee has its key happily, and we receive the key from the provider, resetting the cache time to 5 minutes. And this solution, downsides are that we have double the calls to AWS KMS, and we have double the calls to encryption as a service. But the upsides are that there would be infrequent worst case only for the first time when a user goes into account. So in the morning, maybe the worker goes to his PC and opens the website. There's a first request. We request all the keys, and now we already have all the keys in cache. And if the user or users, any user of the account uses it for more frequently than once in 5 minutes, then we always have the key. And second worst case is kind of eliminated as well, but still present in some cases. And the second worst case is when only the account key cache is present and initialized. And when this second worst case happens, only when the service connects to the encryption as a service. And when it happens, well, in Wrike, software as a service, we are providing our services at all time, and we cannot allow any downtime. So when we deploy the applications, we have our services running, then we deploy the new versions of the services to another server or like site server. We redirect all the traffic there. We update the first one, and when we redirect the traffic back. At that time, all the services which were initialized, the first call would be in the second worst case. But the last case is the best case. And it's very frequent for mostly used accounts. So if the client uses the account, as I said, more than, or at least once in 5 minutes, then all the services would have the key immediately. So what's the conclusion of this story? Well, encryption key management in software as a service is very challenging, and it should be robust and responsive. We need the keys at all times. We don't want to wait for the account keys or any keys to be deciphered or taken from the AWS KMS, which proves that AWS KMS is a very powerful tool when used correctly. And, well, transition to the microservices can reveal the pitfalls you couldn't imagine, because we couldn't thought that while reworking on a small project, we'll hit the milestone of the need to rewrite the whole encryption process of the Wrike Lock. And that's basically it. Thank you very much. It was nice. Read about our company. We have Wrike Engineering and a tech club as well. So, and if you have any questions now, don't hesitate to ask.
All right, let's go with the questions. Stanimir, you go.
About the duplicate calls to AWS KMS. Why don't you send the calls only if close to expiration or how the time of the cache? So let's say in 5 minutes, you only make calls to AWS after only 2 minutes are left. You don't need to refresh the keys all the time. You don't need to double them.
It's free. You can do whatever. We just because, and also this is a good point actually, because if you'll make a call, because the account key cache is 30 minutes. So for example, you're asking why not like 2 minutes before the end, but 15 minutes before the end, right?
No, why you say to double them? It's a downside. You say to double the calls.
Yeah. So double is 15. So we're calling the AWS KMS 15 minutes before the account key cache expiration, not 2 minutes. Because if we will call it and we'll see that something went wrong and we don't have any contact to AWS or the access is withdrawn, we have 15 minutes against 2 minutes of time to prepare for our inability to decode or decrypt or encrypt anything. So we can contact client, for example, and ask like, hey, did you withdraw the access? No? Well, then we will resolve our issue on our own.
Okay. I have a question. How would you explain to a 12-year-old why do you need all this logic on top of KMS? Why can't you just proxy everything to KMS or any other
Yeah, like HashiCorp or something.
Yeah, like Vault or something like this.
Basically,
12-year-old.
12-year-old, yes.
What is the encryption?
Imagine a 12-year-old who knows about KMS and what encryption is.
So our clients, they want the control, but often they don't have the resources to build the control over it, the responsive control. So providing just a single point where you click yes, no on AWS, and the whole data is encrypted or decrypted, can be encrypted or decrypted, is a very nice win for our clients. They don't need to think about much. We are doing it ourselves.
Yes, but imagine that under the hood, so basically, there's a kind of, a toggle that, encrypt all my data, right? And you download the key as a customer, right? And only you have this key. But then it basically passes through this key to KMS, and that's it. That's all it does. And would it or would it not that work, or like why do you need everything else?
If they will be encrypting all their data themselves and decrypting them on themselves, so they will need to come up with a key management solution for their system and their employees who are using Wrike.
So basically, it's like to manage keys, right? It's
yes.
Okay. Gotcha. Thank you. Any other questions?
Sure.
You said that some client stored videos in torrents, but if you encrypt all the data, how do you know it?
Because we contacted that client. Well, huh? No. Actually, this client did not have the encrypted torrents. It was just torrents. I mean, like movies and stuff.
Right. I think we have a capacity for one last question. All right. Yeah, you go.
Do you also index your data for searching and things? Do you encrypt the search index?
No, we don't index the encrypted data.
How do you work with the search? Right? You want to search, navigate the project really quickly. You say, how you encrypt the data. This is it, right?
You cannot search based on the user data.
You can search based on data, right?
Yes.
How do you do it? If everything is encrypted,
They have the decrypted data on their end, and they can search. Like, for example, we have the window where you have the tasks, right? So you search on those tasks, not like on the back end, but just on the front end, because we cannot have control. Like, we cannot just decrypt the data on request and like search among it.
So it's basically, if it's decrypted, they can only search through what's been loaded in the browser.
Yes.
Okay.
How what? Concatenation or sorry? I would be able to answer your question if I would be working in another department, but I don't take care of this particular case, so it works. Magic.
Perfect. Thank you so much, Daniil. This is to you.
Thank you.
From Dev Club, a small present, and then.
Thank you.
Thank you. So, Kat, what is the plan? Do we wrap it up, or do we still have people hang around, or? So yeah. From the Dev Club side, this is it. Like there gonna be no more talks tonight. Well, thank you so much for joining us. Thank you so much, Playtech, for being such an awesome host. Hopefully, we also managed to make a good impression, and this is not the last time we're around. And the next one, stay tuned. It's gonna happen in December at ST Energia preliminarily, and see you in a month. Thank you. Bye bye.